You may have learned that an alkali metal reacts with water to form hydrogen gas and the corresponding metal hydroxide. You may have also learned that the reactivity of these metals with water increases moving down the group. That lesson is actually available right here on this channel. In this lesson, we will learn about the concept of shielding and how it contributes to certain observed trends, such as the reactivity of alkali metals with water. Moving down group 1 of the periodic table, atomic radius increases by 1 electron shell. Lithium has 2 electron shells, sodium has 3 electron shells, potassium has 4 electron shells. We know that these alkali metals can lose their lone electron in their valence or outermost shell to form an ion with a positive 1 charge. In fact, this is what happens when an alkali metal reacts with water. The ease of formation of the ion is directly proportional to the ease of losing that electron. Moving down the group, the outer shell electron becomes further from the nucleus. This decreases its attraction. Shielding is defined as the decreased electrostatic attraction between the nucleus and the outermost electrons due to the presence of additional electron shells. Shielding increases, this again decreases the attraction for the outer shell electron. Although nuclear charge increases, the atomic radius and shielding, as mentioned, outweigh this increase, so moving down the group, it is easier to lose the outer shell electron. We can think of the nucleus like a magnet. A magnet is able to hold onto an iron nail. Wrap the magnet with a sheet of cloth, and it would not hold onto that nail as effectively. Wrap it with another sheet of cloth, and it would be even harder for it to hold on to that nail. The same idea applies to the alkali metals. If there are more electron shells present between the nucleus and the valence electron, the attractive force of the nucleus to that electron will be weaker. So the greater the shielding, the easier it is to lose an electron to form an ion. The term ionization energy is used to describe the amount of energy required to remove an outermost electron from an atom. Increased shielding means that ionization energy is decreased. The same trend is observed moving down any group in the periodic table. Let's take the halogens as an example. Reactivity decreases moving down the halogens. Halogens each have 7 valence electrons and therefore accept an electron to form a complete octet and a negatively charged ion. So the nucleus of a given halogen would need to attract that electron. The energy released when an electron is added to a neutral species to form a negative ion is known as the electron affinity. This determines the affinity of a species for attracting electrons.